Hey guys, so this is the video that I wanted to make of my project. So what I got going on here is this base right here. I 3D printed this. It was available on Thingiverse. Obviously it holds the Raspberry Pi, which this is the Raspberry Pi 4 gigabyte. It also holds a Raspberry Pi Zero, and I have all the stuff to test that with, and the program theoretically would work. And so, of course, I got different cases here, and I'm going to use the bottom one of these cases for this test purpose on with the Raspberry Pi. I actually have like 6 of these now in my house doing various things. But right here I have an LCD screen in this 3D printed base. I put a long breadboard there. I have the short breadboard just sitting there so I can move this around as needed. And then the ribbon cable, of course, is hooked to the Raspberry Pi. Along with the whole setup. And as you can see, I run a lot of wires from here. So these are my 5-volt powers. This one is GPI 22 and 23 and 24. 22 is over here. I'm using it, and then I'm using a ground here, and then a ground here, and then also over here for the LCD, I'm using the SDA and the SCA ports, as well as a ground and a power. So the LCD is a replacement because the original that came with the kit kept frying wires going to the 5 volts, and so I couldn't have that. But I didn't know that I'd already had this replacement ordered just in case, and sure enough, I actually needed it. And so it operates fine, works great. But then for what I've got going on is an ultrasonic range sensor to tell the distance for a distance calculator is what I kind of called it. I have an LED light, a red one, for the project as well. The assembly language that I have operates the LED light. As for the ultrasonic range sensor, it basically has this wire that goes to the GPIO 23, the green one, and then which is, let's see if you can see it here, but it's the trig. This red one is the power, VCC. Then the black wire here is actually going to the ground. But then on the echo wire, again, I don't know if that's really visible all that great, but the echo wire, the third one there, is a resistor that goes over here to another resistor. So I didn't have any 2K resistors. So I ended up just using 2 in parallel, which obviously equals 2K to go to a ground. And then coming off of that one, in that same line, I have this yellow wire connected that goes over here to the GPIO 24. So that is ultimately the echo, and then the green one is the trigger, which basically means one of these, it's going to trigger a sound out, and the other one's going to receive the echo back. Now, the programs that I have 3 files. I have what I've called the distance LCD, the on and the off. So the distance LCD is obviously coded in C, and the on and off are coded in assembly language. In the distance LCD, I actually pulled this originally from the Freenove, which was the kit that we bought. Tutorials or templates or whatever you want to call it. There was a Python script as well. I just felt more comfortable when I got into it with the C syntax. I don't know the C language, I just felt more comfortable with it with the ones that I do know. And so it basically calls in a lot of things. The wiring pi, these different ones at a time. Some of these were there that are not actually needed now. Like this time isn't actually, I mean it is, but it's not needed. No. This one was needed. I believe it's this one is the one that's not needed for the program. Then the PCF 8574 is used for the chip on the back of this LCD. Right there, that chip, and it handles that because otherwise I have LCDs without the chip set up on the back, and I would have to have soldered on all those and then run each one of those, and there was just too many wires that I wouldn't be able to run the other things that I wanted to. and then the LCD, which is a few other things. So kind of come in here, and I had to write some of this or combined different programs together. This gives kind of the max distance. Now this is in centimeters, and then this is basically the time, how long before it basically times out. This is the address. This 3F is the memory address, but if it was actually I believe it is a Raspberry Pi, maybe a 1 and 0 would use the 2F. It's a different location for where it's actually going to be located in the wiring. So a lot of this is gonna, but here's a key point. This extern void on and off. I have to assemble the file together with the on and off assembly files, and this basically calls that external part of the compilation. They're compiled with it, but it still calls it those points from a separate file, quote unquote. And then it does some, programming things. This is what it does when it calls the print distance, but down here is the main. All right, so it calls the wiring pi, and it prints out some things. Welcome to my measurement program. Kind of gives you some information, what's going to happen. It type in your desired distance in inches, and when that's met, a red LED light will turn on, which is that LED light right there. So then it does some more things, but then it gets down here. Turns on the LED, the backlight, all of that good stuff. Please enter your desired distance. All right, and so it pulls whatever the user entered and places it in user num, and then it calls the print distant, and it inputs that user num, whatever the user entered, into the print distance. So you go up here to this method, the print distance, it pulls that number in, and then it declares a few things. Then it marks the trig pin as the output and the echo pin as the input, so that the wiring is now knowing what it's about to do. So it's about to sends a little pulse to the trig pin, and then it receives it back. Now when it receives it back, originally the program wrote this in centimeters. However, I didn't want to use centimeters because, well, I'm not from Europe and I know inches better. So I basically took all of this formula, and in order to get inches from centimeters, you divide it by 2.54, and that gives you inches. So it's basically all there is to making sure it comes out as inches rather than centimeters. And then I placed it on 0, 0, the LCD. There's 0 and 1 basically. 0 is the top line, 1 is the bottom line. And that means basically this is the beginning of the first line. And this is what it outputs. Distance, dist, because if I put distance, it's too long. But then it kind of gives that number that is being read and in inches, display the distance on the LCD. And then here's where the assembly language comes into play. If the distance is less than or equal to the number that is entered by, or over, or by 0.05, either way, or greater than or equal to 0.05. So it's basically saying technically 0.05 below and 0.04 above, I believe is what it technically is. But if it is in that distance, it calls the on file. If elsewise, it calls the off file. And that's pretty much all there is to this. It continuously runs, so it'll continuously show the new distance over and over and over. However, here's the assembly file. So for any of the students, you can find these files inside of the assembly language book that we had. However, there was a little bit of a problem with it, as in he had a few commands, like a close command here, which counteracted kind of this, and it also pulled from this. So it caused a lot of segmentation faults, and that wasn't meant to be there. Really all that's happening here is it's pulling in the GPI OBase, but then it's loading up a memory address for a certain pin. And in order to turn the LED on, it has to basically move over and wipe 3 pins to clear a bitwise to clear these 3 bits. I don't know why I said pins, I meant bits. Clear the 3 bits. And that, turns the LED on. Now, over here is almost the exact identical file, except it's kind of doing a little bit of a different thing. So it's actually using it to turn the bits off rather than on, and I accidentally closed that file. So, bad. And then the other problem I had that I finally was able to fix is, in order to turn the LCD on and off, the code he gives, you'd have to run it as a super user using the sudo command, but it doesn't have this GPIO part into the memory file address. And the problem is, when it's just the memory address, there's kind of some safety features that prevent you from doing that, so that you don't, mess up your operating system. However, there is this one, the GPIO mem, that you're able to write without the sudo command. So with the sudo command, I was able to get these working individually, but then when I would assemble them all together into the distance LCD, it would not read a distance with the sudo command due to some memory address issues with where things are placed in location when you use the super user to do that. So I was having a lot of a problem, and I spent a lot of hours to figure out that I finally found some information that this was able to be used, and really that it existed. And so I'll provide all these files. You guys can look at them if you'd like. So there's kind of how they all work. And so in order to assemble it, provided kind of the command here. So let's copy it, go down into terminal. I'm in the right folder, but let me just do it this way. So assemble it, so run. Just gonna run it, just like you would any other assembly program. Now it says, welcome to my measurement program. You can use this program to measure short distances. Please enter a distance you would like to measure in inches, and when your desired distance is met, the red LED light will turn on. Have fun. When you're done, press Control-C to end the program, because it is in a continuous loop and it will not stop until you literally physically stop it. So please enter your desired distance. So I'm going to say 10 inches. And that's all you see on the screen. However, now, as you can see, this screen now begins to give information. This LCD does. Now I place this here, and I'm going to use this ruler to kind of get a general idea, but the ruler's, it's not a perfect measurement kind of thing. And so that says 9.50, 9.6. Oh, and the LED came on for just a second. Sometimes it'll settle better, and it works better once it's settled, but being ultrasonic, there is a little bit of issues. I have the longer distance you get with it reading properly, the closer distance you read, the better that it does. As you can see, it likes to bounce around a little bit. And yep, there it is. So as you can see, the LED's on, it reads 9.97, so it is pretty close to 10 inches. And then the moment that you pull it forward, 8.21, the LED is off. And so that is my final project. Had a lot of fun with it, enjoyed it, learned a lot of things with learning some C language along with assembly language, and how some different things operated as far as using memory addresses and the GPIO pins within that. So it was real fun, had a lot of fun, enjoyed seeing what everybody else's is as well.